We have the infinite series of 1 divided by n squared, and we want to use the integral test to show that this infinite series converges. And the integral test says that if the corresponding continuous function is positive, continuous, and decreasing on the interval 1 to infinity, then to show that this infinite series converges, then we need to show that this corresponding integral from 1 to infinity converges. And so if we let the sequence a sub n be 1 divided by n squared, then the corresponding continuous function f of x is the function 1 divided by x squared. And we need to show that this integral right here converges. And specifically, we need to show this function right here, the function f of x, which is the function 1 divided by x squared, converges. Now, and then this is the improper integral 1 to infinity, so we'll rewrite it using limit notation. So this is the same thing if we do 1 to b, and as b runs to infinity. And then this is the limit let's rewrite 1 over x squared. 1 over x squared is the same as x to the negative 2. And then to find the antiderivative here, we add 1 to the exponent. So x to the negative 2 plus 1, the x to the negative 1. And we need to evaluate from 1 to b. But x to the negative 1 and then we need to add 1 to the exponent, we get negative 1. And then we also need to divide by negative 1. X to the negative 1 is the same as 1 over x, so it'll be 1 over x dividing by negative 1, which is just negative 1 over x. And then we need to evaluate from 1 to b. So we put a b in, replace x with b, then we get negative 1 over b. And then minus, if we put a 1 in here, then we get a negative 1. As b runs to infinity, this 1 over b will run to 0. Minus negative 1, then we get 1, which equals to 1. So the this infinite series, the infinite integral right here converges to 1. and therefore by integral test, the infinite series right here also converges. Now, the infinite series here converges to 1. That does not mean that the sum here is equal to 1. It just means that it converges to some finite number, but it's not 1. And so we want to know what that finite number is. We can use computer program, maybe run 1 to 1,000,000, and that will give us an approximate value for this infinite series, but it's not 1. The integral 1 over x squared equal to 1, it means this. This is the graph of 1 over x squared. This is the area between the graph and the x-axis from 1 to infinity. So this infinite area here is equal to 1. But the sum, the infinite sum, is not equal to 1. Here we have the infinite series, which is the first 100,000 terms. The first 100,000 terms is about 1.64492, and so we can see that it's not 1. And so one more time, whenever the integral converges to some finite number, and then all we can say is that the infinite series also converges to a finite number, but not the same number. So this integral converges to 1, but the infinite series does not converge to 1.